This week on Quality Digest Live, we look at the right way to implement lean in higher education.
Plus, do you have the right mindset for innovation? We'll find out when we come back. Welcome back to Quality Digest Live for August 28th, 2015. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. So, has your business ever dealt with a bottleneck caused by your inability to mechanically check parts quickly? Have you ever missed a shipment deadline because your coordinate measuring machine couldn't measure a production batch in a timely manner? Could you manufacture more parts if you only had the ability to inspect them faster? Well, if you answered yes to one or more of those questions, most likely your bottleneck is the speed with which you can measure using traditional touch probe methods on a CMM. So although CMM touch probing is or can be very, very accurate, it is also rather slow. Then that is why more and more companies are turning to laser scanning technologies for 3D part inspection. Our next guest is Alex Lucas of Nikon Metrology, here to discuss some of the advancements in laser scanning in what it offers over touch probing. Hi, Alex.
Hi, Dirk. How's it going?
Oh, pretty good. So just so we can set this up ahead of time, obviously we're going to be talking about laser scanning, and obviously we're going to be talking about probably Nikon equipment. But Nikon itself actually makes touch probing as well, right? I mean, you guys do touch probe CMMs as well as laser scanning CMMs. Is that right?
Absolutely. One of the things that we've really wanted to bring to the market is the capability of having a multi-sensor inspection system. So what a CMM obviously offers is a history of being able to use a touch trigger probe or even an analog scanning probe to be able to inspect a lot of data very accurately. But something that we've introduced, and really over the last few decades, come through a couple different generations of laser scanners that are starting to narrow the gap with what you can analyze or measure with a touch probe.
Well, yeah, I mean, I was going to say, I mean, I know that one reason some shops didn't use laser scanners in the past is because, you know, traditionally, I'm guessing, I'm talking maybe 10 years ago, you tell me, is that the accuracy just wasn't there. And so if you wanted accuracy, you really had to go with like a touch probe. Are laser scanners getting close to competing with traditional touch probe CMMs in terms of accuracy?
Absolutely. The nice thing about the laser scanning, obviously with my own biased view being with Nikon, is what we've been able to do is introduce the optics that can match with what we can do from an acquisition standpoint. So historically, we can always go through and collect the point cloud information, but when you combine that with obviously the same or similar type of optics that you would find inside of a Nikon DSLR camera, you're going to get very superior results when it comes to the accuracy of that scan data. And obviously that scan data just trickles down into what you can actually inspect. And then when you look at the correlation between laser scan results and tactile results in a CMM, they're starting to get within 5–10% of your overall tolerance zone. So more than comfortable for most customers to make the leap to laser scanning.
And so have companies like Nikon and the others, obviously Nikon isn't the only company that does any kind of laser scanning. Have all of you guys seen the market kind of evolving over time, where you're seeing more and more shops that might have traditionally gone with a CMM now actually saying, okay, well, I guess it's time now to get a scanner?
Absolutely. I think one of the things, like I'd mentioned, the multi-sensor inspection methodology, being able to use both a laser scanner and a touch probe for a given part is a critical thing. I think for when we show you the webinar this coming Tuesday, we're going to focus on the laser scanner, but one of the things that's been critical to us in listening to customer demands is the fact that they still have certain features and certain things that they want to inspect with a touch probe. For people that are familiar with checking parts in a CMM, nothing is more critical than setting the correct alignment frame and getting your datum structure measured and tied in as accurately as possible. And that's something that certain customers still prefer a touch probe. From there, once they have the alignment set, they can go back to the laser scanner and do all the rest of the inspection in a much quicker fashion.
And also, I guess we should point out that there are some things that scanners, laser scanners can't do that you still really need a touch probe, like deep, narrow holes and that sort of thing, right?
Absolutely. When it comes to an accessibility issue, nothing's going to be able to match a touch probe, especially if you have something like a 200, 300 millimeter extension to get inside of a feature. And then obviously certain types of materials, the laser scanner is going to struggle with. When it comes to glass, anything that's going to be transparent or translucent, even like certain types of plastics, the laser scanner is going to struggle. But something, and again, just looking at where the market has come and where the latest generations of scanners are at, when it comes to highly reflective materials, we've gotten to get much better with collecting data. Now, obviously, if it's a mirror type part or something that's purely made out of chrome, we're going to struggle with something like that. But I would say for the majority of materials that will customarily see sheet metal components, even certain machined aluminums, we're able to gather data without much struggle at all.
Okay, now let's talk about the actual laser scanners for a bit. I mean, we are all probably familiar with the specs. You know, hundreds of thousands of points per second, captured. So I mean, in a few seconds or a few minutes, you can capture millions of points. But what does this mean in a practical sense? I mean, what are the advantages of being able to do that?
Well, there's a few key advantages. Obviously, the speed is first and foremost. I think that's why people want to look at laser scanning, being able to check more parts in a shorter amount of time. There's quite a few other corollary advantages that you can have with laser scanners, though. When it comes to being able to fixture and hold a part, the fact that with a laser scanner, you don't need to physically contact it means that your holding fixture can be much more simplistic. You're not having to worry about any tactile measurements moving the part as you're trying to inspect it, or somehow skewing your end results. Same goes true for certain types of material. Now, obviously, if it's something that's more fragile or prone to deforming under just even a light contact from a touch trigger probe, a laser scanner will instantly take care of any concerns with that because of not having to touch the part. And again, with the speed, the fact of that is we're collecting typically hundreds of millions of data points for a given part, but in a lot of cases, they're not points that would be normally checked with a touch probe. So when it comes down to it, and the analogy that we like to use is using a laser scanner is somewhat like using a paintbrush. We're going through creating a digital rendering of the part. So even if it's not something that the touch probe would physically contact, the laser scanner is going to pick it up. So it's almost like you get more bang for your buck with inspecting with a laser scanner.
So I'm assuming part of the advantage of that then is that there are features that you could qualify that would take a lot longer, or might even be almost impossible to do with a touch probe.
Absolutely. And the nice thing is with the laser scanner, if you're looking at just a specific feature, a very simple circle, and if you're going through and going to do some GD&T analysis off of that, the laser scanner is going to resolve that feature, that circle, by measuring thousands of points. With a touch probe, the speed is going to be a function of how many points that you want to measure. And then there's the trade-off between how many points that you want to measure to get a good, accurate understanding of the roundness of that feature or its true position, relative to how many points the laser scanner can give you in a fraction of the amount of time.
Okay. Well, we're going to have a webinar on this very topic next Tuesday. So if our viewers are interested in laser scanning, and we're going to have a webinar. It's called Increase Your Inspection Productivity with the Insight L100 laser scanner. Again, that's next Tuesday, September 1st, 2 p.m. Eastern, 11 a.m. Pacific. Alex is going to be the presenter, and I will be the host. So be sure to sign up for that. There should be a link in the story that is, we're linked to the story, but underneath the player page in there, there's a link to the webinar, and be sure to click on that and come out and learn some more about laser scanning, what it can do for you. Thanks, Alex, for joining us this morning. Thanks,
Mike. Thanks, Dirk. Thanks for having me. I appreciate it.
Sure, no problem.
Yep, we'll
see you Tuesday.
See you Tuesday. Thanks, Alex.
Bye, guys.
See ya. Yeah, and everyone out there, also remember, we send out e-blast on this, on our webinars as well, so you'll have an e-blast in your inbox probably Monday morning. So if you you don't have a chance to get out to the article that Alex wrote and register there, you can register through the eBlast and check out that webinar. Going to be a good one. Going to be very technical, so if you're in that space, yeah, make sure you check it out. All right. Thanks, Dirk, and thanks, Alex. Okay, well, methodological errors in lean. Methodological errors in lean,
Say
I
it
said.
just one more time.
Methodological errors in lean. As Dirk is tweaking me, I had a bit of a problem pronouncing that. But I've been practicing. Methodological errors in lean for higher ed by Bob Emiliani appeared in Wednesday's issue of Quality Digest Daily. You can see it right there. That's the article that appeared in Wednesday's issue of QDD. Now, Bob Emiliani is an author and he's a frequent QD contributor. He's written for us now for quite some time. He's an academic who teaches lean and management, and he's worked in industry in engineering and operations for quite some time. So he has a broad and I'd say rather unique perspective on lean, both in the field and in the classroom. And he says here in this article that those in academia must apply lean principles for themselves. They must take what is going on in the field and apply those principles in order to more efficiently do the functions that academia needs to do. It's a service industry, transactional environment, really, if you think about it, with a lot of inputs, a lot of stakeholders, a lot of inputs. So you know, it makes a lot of sense that he, as a professor who's teaching lean, would want to apply lean principles as they're applied in manufacturing and in the field to education. So he actually has 12 points in this piece that he talks about, and I want to just highlight a few of them real quickly for you, and you can read the rest of them in his article because it's interesting the way he looks at this stuff. But I'm gonna break it down for you because I couldn't any way get into it as deeply or as accurately as Bob Emiliani. But I'll give you a couple of quick points, 3 quick points that he talks about here. First one is he refers to programs, initiatives, and events as being something that is often done with lean. And he says this really looks at lean piecemeal. Lean, as he says, and as we all should know, is really about flow across the organization and getting rid of organizational silos. And when you look at lean as a series of programs or a series of initiatives or events or blitzes, whatever you want to call it, that really gets you in the realm of continual improvement. And we've come to learn the difference between continual improvement, which is a series of kind of stuttery steps, and continuous improvement, which is much smoother, where you're constantly looking for opportunities to improve. And the example he uses in organizations, they have lots of batched information processes. And the systems that handle those processes are done in a very old-fashioned batched way. And he says we should get rid of that. We should have flow across these systems. Another one he talks about is this idea of suggestions and recommendations. And this is really a carryover from traditional management systems where findings were made and they were reported upwards, right, in the old days. And what would happen is management would slowly mull over those suggestions or the opportunities that were revealed, and they'd maybe take some action from the top down after a period of time. Well, that's really not the way it should be done. It's really not the way in a Kaizen or a lean environment it is done. It really, what you want to do is you want to take the action as close to real time as possible, and you want to have empowered Kaizen teams to make those changes. You don't want to have people that you've empowered to be experts have to say, well, we know what we have to do, but let's report it up first and wait for weeks to get a response and then have it be filtered through a bunch of managers. They want to be able to make those changes right away on the spot. And the example he uses within universities are administrative departments. They have huge divisions of labor in university administration departments, academia, where you have some people who process things, some people make decisions on things. There's really not a lot of connect there. It's really many, many different silos. The third one he talks about is this idea of focusing on savings, not value. Reducing costs, of course, we know are important wherever you are in any kind of an operation, but lean leaders really need to unlock value first and foremost, and you really need to think about value as opposed to cost if you're going to really undertake lean in the proper way. And the example he uses there is that university lean leaders really have to improve information flow, and they have to create learning organizations across the enterprise, right? You can't really focus on how much that costs you if the value is there for your stakeholders, your students, your professors, whomever it may be. Now he has 12 of these, as I mentioned, and they're based on his experiences and his observations, again, in the field, and he's got a lengthy resume. Bob's been doing this for a while, and he knows what he's talking about. And in this piece, he kind of looks at industry in a very positive light. He's making a point here to say, well, industry does this and we need to do in academia. Well, we all know that industry doesn't always do it exactly as well as it could be done. So I think that wherever you are, whether you are an academic or you're in industry, manufacturing, service, transactional, whatever, these are some really good practical pieces of advice. And if you maybe want to reverse engineer some of these things and say, well, industry supposedly is doing this, we're going to graft it onto academia, maybe we need to reverse engineer it back into manufacturing a little bit. That's a good idea too. So I would say take a look at the article. Again, it's right below that video player page, right where they all are. And check out all 12 because they're really good, very valid points that Bob's talking about.
Yep.
Yeah, good stuff there.
Good stuff by Bob Miliani. That's right. That's right. Methodological. Methodological. That's right. I don't have any tough words in mind. In his column this week, Innovation is about mindset and lifestyle. Robert Wilson talks about his first encounter with Retsina, which is a white wine from Greece. And the most charitable description of Retsina by newcomers is that it tastes like turpentine.
Mm-hmm. Yummy.
But Wilson had been given this wine by friends whose parents loved it, so he concluded that there must be something about it that should be good. He just needed to work with it a bit. So he kept drinking a tiny bit each day, kind of an inoculation. He had it with a dinner at a Greek restaurant to see how it went with Greek food. And over time, it went from being repulsive to simply less repulsive. Unique is what he called it. He exposed himself to something new, something that was initially awful to him. When you experience new things, writes Wilson, you generate new information and data that you store in your brain. So to think creatively, he writes, you need a variety of knowledge from which to draw. Part of being an innovator is to experience something in a different context. Wilson calls it a mindset. Sometimes the context is a choice, and sometimes the context is thrust upon you. And this kind of reminded me, when I was 17 and a half years old, right out of high school, I went to Europe for a month and a half.
Dirk's European vacation.
Dirk's European, and a lot of interesting things happened on that trip.
Yes, they did.
But there was a life-changing thing. I grew up hating cheese.
Okay.
I did not like, my dad ate cheese all the time, and I would try it. It wasn't like I looked at it and went, oh, gross, I tasted it many times. Just could not stand it. So I'm in Europe. I got 2 weeks left or a week and a half left of my trip in Europe. I had like $100 left. I had no money. And I'm like living on like nothing, whatever I could scrounge. I mean, I was eating practically nothing a day because I had 2 weeks before I had to take my flight back, right?
Yeah, you were right out of high school.
I was right out of high school.
So $100 in 1944 was really a lot of money.
Exactly,
so I mean,
exactly. Yeah. Just didn't go anywhere then. So I'm walking down this country road in the Netherlands, and in the middle of the road, I spot a paper bag, a lunch sack. Okay. I'm going, oh man, a lunch sack. Been run over a couple times. I go up there and I grab this lunch sack and I open up. Inside was a plastic bag. And inside the plastic bag was a sandwich. And I'm going, oh my God, thank you, Jesus. And I open up the bag and I pull out and I open up the 2 pieces of bread. It's a cheese sandwich.
Of course it is.
A freaking cheese sandwich. I'm going, I don't care.
Yeah.
I bite into it, and I bite into this cheese, and it was like the most delightful thing in the world. It was cheese with treads on it, and it was awesome, bits of asphalt, and it was like, I couldn't believe how delicious it was. Mm-hmm. And it wasn't just then. I mean, once I got back home from Europe, I loved cheese from that point on.
Wow.
Now, nothing had changed. The cheese tasted the same as it had always tasted. My taste buds hadn't changed, but the context had changed, right? I experienced it in a different context, and that opened up a new
world of cheese.
A world of cheese. Yeah. And this is, when I think about this, I think about, I don't know if you guys have heard the name Spencer Silver. When he was working for 3M, he tried developing a super strong adhesive. And what he ended up with was exactly the opposite, a weak adhesive. In short, he failed at his initial project. But the interesting thing about this weak adhesive was that it could be used over and over. It wasn't until 5 years later that Spencer and 3M chemical engineer Art Fry came up with the idea of using the adhesive on paper. And the first Post-it note was born.
Yep.
So sometimes it's not about thinking outside the box. It's about getting rid of one box and using another. Completely change the concept, change the context or the mindset, and innovation may follow.
Yeah, that's right.
A whole different perspective on life.
You know, you mentioned that different neurons, neural pathways are created. It actually is, and that's really what happens is different connections are made in the brain when you try and experience different things, and from that comes innovation and creativity. Yeah. Good stuff. He talks about that a lot, Robert Wilson. He's really good.
Kind of innovation. That's his gig.
And creativity. Yeah, good stuff there. Yep. All right. Well, last month, Dirk and I spent the better part of a week with our good friends in the Coordinate Metrology Society at their annual conference, CMSC 2015 in Hollywood, Florida. Now, the CMSC always presents a chance to get up close and personal with the best hardware, software, and peripherals in the field of close tolerance, large volume, and portable metrology. For those in industrial sectors such as aerospace, automotive, and shipbuilding, to name just a few, portable coordinate metrology systems are absolutely essential. So while we were at this year's show, Dirk and I taped some video segments highlighting some of the CMSC's ongoing work. On this very program, on July 24th, we aired the interview that we did with incoming CMSC chairperson Rena Malari and her predecessor Ron Rode. The following week, we showed you one of the great new products debuting at the show, the Inca 4 photogrammetry camera from Geodetic Systems, Inc. Now, we're going to bring you another interview collected at CMSC 2015. In this segment, Dirk sat down with Keith Bevan of the National Physical Laboratory in the UK, as well as Gary Confalone, President and CEO of ECM Global Measurement Solutions. These two gentlemen have been working closely together on the CMSC's Level 1 and Level 2 personnel certification, as well as a training program that supports it. So, these are two very smart guys with a lot to say. So without further ado, let's roll the tape and listen in.
Okay, guys, so we're at the CMSC show, and we're in the measurement zone, and obviously we've been talking about for a long time that you have been creating a certification program. But one of the problems from what I understand is that people who want to study for it don't have a single point for a body of knowledge that they can study from. Is that true?
Until now.
Until now, okay.
Yeah. It's been, well, this all started back in 2008 with the certification committee coming to, bring the Level 1, Level 2 exam. After we got the Level 1 exam and implemented it at the show.
Which is the written exam, that's the knowledge exam.
Yeah, okay. The knowledge exam. The people were panning that there was no way to study for it. So we kind of sat back and to see what would happen. We want an industry to do this. This is all people volunteering to participate. Went a year, nothing really happened. So, me and Keith were talking one night and decided, let's go forth and, put together a program so people can study and have a course that's more of a preparatory course for the certification.
And what kind of information is that? I mean, we should say that this is specific to large-scale precision 3D metrology, right?
That's correct, but there's elements that are core, whatever metrology you're doing, to make sure that when you are actually doing coordinate metrology, you have that knowledge and understanding to be able to make informed decisions, good behavior, and also then be able to understand and answer some of the knowledge questions that are associated with the certification program.
And this body of knowledge has been lacking, not just here in the United States, but I think you told me that even in the UK or Europe, that nobody's really consolidated it for this specific field, the 3D metrology. Yeah.
For this, it doesn't exist in the UK as it is in this moment in time.
And so how have people been coming up to speed? How have people been learning to do this?
Well, they've basically been working with, obviously, the equipment manufacturers and then learning all about the software, the equipment, and then going and applying it. But what you're finding is that there's people coming into the industry who are then using that piece of equipment or being taught that piece of equipment with no metrology knowledge whatsoever and expected to do the same job as somebody who may have 20, 30 years experience.
And obviously what you guys have learned here is those people in the tests that you've done, they actually don't really necessarily know what they're doing.
There is an element of that. Know what they're doing is maybe a little bit strong, but actually within the measurement zone over the years that we have been doing all the different studies, what it's allowed us to do is to prove to people that there are really good practices, there are elements about behavior that really will contribute into making good decisions when using all the technologies in large volume.
Yeah. And what is the body of knowledge that you're putting together? If you can just kind of outline some of what people might expect to find in this.
Well, there's 5 categories. They target in on blueprint reading, equipment knowledge, meaning basically all the equipment that's at the show you should be familiar with. Ethics,
preparing for measurement, what you do during the measurement, what you do after the measurement. So it's not just about pressing the button and looking at the software.
And how to handle the data.
Yeah, exactly.
And, what to do with the data, how you report it, how you look at it, and different coordinate systems. And
when you were pulling all of this together, did you find particular types of information or particular type of knowledge that was actually hard to find, like nobody was supplying it, for instance? Or
well, one of the things that we kind of touched on, a lot of the people that are getting in this field are brilliant. We hire engineers, a lot of entry-level engineers. Nobody's heard of metrology. Nobody knows anything about it. Most people think it's the weather when they first hear it. But so this was a good way to take people that have been working in the field and see what their knowledge is. For me, it was particularly important because when I hire a contractor or hire somebody to help me, and they say they're an expert, I want some type of certification or some safety net so I know, I get what I'm asking for.
So when people want to study for this exam, the level one exam here, where would they go to find this body of knowledge? Is it something that they can download all online? Is it published in a book? I mean, where do they get this?
Yeah, well, the body of knowledge is, all the topics are listed on the CMSC website. Okay. There's also references to, various sources that they can look up information, whether it be on the NIST website or the NPL website. But on our website, we also have our outline of what's covered in the course that's included in the body of knowledge.
And is there training available on the body of knowledge?
Yes, there's a review course, and that's what we've put together, okay. NPL and ECM. There's a review course for the certification, and it covers everything that's in the body of knowledge. Or if you take this course and things aren't familiar to you, then you wouldn't want to become certified. You wouldn't want to sit for the exam. The course should be a refresher course for everything that's in the certification. So it goes over, thermal coefficients of expansion, things like repositioning of equipment, 3D best fits, GD&T, blueprint reading, things that you would expect an expert in the industry to know.
Are there any particular topics that, for instance, GD&T, I'm thinking, is that one particular topic, or are there other topics that people really have no clue about?
I think it's really about the measurement strategy. So taking the blueprint, once you understand the best way or the good practice way of being able to set up things like the coordinate system, or how to measure certain features in particular ways, what is the number of points that you're going to do to measure a specific feature. There's lots of questions that you should be asking yourself when you're looking at that blueprint. And then setting out a real strategy that will take you forward, knowing that you're confident in the numbers that come out the other end, which is really what, when you get through the body of knowledge, it talks about data handling, statistical analysis. So there's a lot of things and detail in there that you can really make a difference with the information that you actually obtain.
Does this assume the level 1 certification and the body of knowledge that it's based on? Does this assume a certain skill level or certain knowledge level to begin with? I mean, could anybody come in and study this and come up to speed and pass the certification test, or do you need some sort of, I don't know, college background or work background already in metrology to grasp it?
Yeah, you don't need a college degree to take the exam, but there is a certain level, and it's all specified on the website, the criteria that you would need to come in before you took the certification. I think, is it 2 years? 2 years in the field. If you had a PhD in engineering and you sat for the you may not pass it, because a lot of it is knowledge of hands-on things that you would learn. That they're just not intuitive. These are things that you'd have to experience to be able to get them correct on the exam.
Okay. Before we go, you said that training in this body of knowledge is available already from here in the States and also in the UK. Can you just give us a little bit, if people want, in either location, if people want to find out more information about that, where would they go?
Yeah.
Well, from our perspective, they would go to the MPL website.
National Physical Lab in the UK? Okay.
Yeah, so mpl.co.uk is basically got a training section where you can look at all the different types of training courses and all the different good practice documentation that's available for people to review.
And is this taken on site?
It is.
The training's on site?
Yes, it can be taken on site or come to a location of their choice.
Okay, and what about here in the States?
Yeah, in North America, you go to eastcoastmetrology.com. There's a list of all the courses, the body of knowledge, the certification, the instructions, and a link to the application for the certificate to sit for it. And we can come to your facility to give the training and to give the exam, or you can come to our facility in Boston and sit for the exam. The exam is online, so it's pretty easy to make it mobile.
Okay. Guys, appreciate
Thank
it.
you.
Hey, thanks a bunch.
Thanks a lot.
Yeah,
Congratulations, by the way, on the certification program. Sounds like it's going great.
Yeah.
Thank you.
Okay.
It is. Thanks.
Well, there you go. That is the interview that Dirk conducted with Gary Confalone and Keith Bevan at CMSC 2015, talking about training and the CMSC certification program. Really good interview there, Dirk.
Yeah, thanks. Yeah, no, it's what's going on with the CMSC with the metrology certification is really good stuff. So
Yeah, breakthrough. Really, really interesting. We'll continue to track that in upcoming CMSCs as well, of course.
And speaking of metrology stuff, don't forget our webinar next week with Nikon laser scanning and kind of the advantages of laser scanning, what it can bring to you over touch probing. So you want to check that out. That's next week, next Tuesday, September 1st, 2 p.m. Eastern, 11 a.m. Pacific.
Yeah, increase your inspection productivity with the Insight L10 L100 laser scanner. So yeah, Tuesday. Check out your email for a registration link to that one. All right, well, thanks everyone for joining us. Thank you again, Alex of Nikon for joining us, Alex Lucas, for coming on and giving us a preview of that webinar. Thanks to all of you for joining us as well. We'll see you next week for a big week of Quality Digest and of course QDL here next Friday. So have a great weekend, everybody, and we'll see you then.
So long.
Bye.